हेलो एवरीवन, वेलकम टू पीडब्ल्यू। वेलकम टू पीडब्ल्यू। एक बार जल्दी से बताइएगा क्या ऑडियो ओके। वंस अगेन, हेलो एवरीवन, वेलकम टू पीडब्ल्यू। सो in today's session we are going to discuss about the questions based on the previous year. Okay, please let me know by writing in the comment section whether audio and video everything is perfect or not. Please let me know by writing in the comment section whether audio and video everything is perfect or not. So this session is going to give you a great understanding of the entire subject. Okay, because it is covering almost entire syllabus of your GATE. Okay. Good afternoon, Mayur. Clear? Great. Now please observe. In this session I am going to discuss some questions on transformer, DC machine, induction machine, as well as from the synchronous machine. Now please observe first question. You need to try it. If you already solved, then also at least try to solve it and find the exact answer. Okay, so that makes you that is going to help you to understand the concept in a more better way. Okay, please observe this question. Magnetic circuit shown below has a uniform cross sectional area and air gap of 0.2 centimeter. Mean path length of the core is 40 centimeter. So mean path is given to you. Mean path is given to you, that is 40 centimeter. Further, assume that leakage and fringing fluxes are negligible when the core relative permeability is assumed to be infinite. The flux density computed in the air gap is 1 Tesla. So when it is being assumed that the core material will have infinite permeability, under that condition the flux set up in the air gap is 1 Tesla. Okay, now please observe, with the same ampere turn, it means with the same MMF, if the core relative permeability is assumed to be 1000 linear, so it means with the change in magnetizing current your relative permeability is changing linearly. Okay, so it is given that 1000 is your relative permeability. Further saying that the flux density is in Tesla, calculate in the air gap is calculated in the air gap is. So you need to find the flux density in the air gap when relative permeability of the material is changed. Hoping all of you are able to understand the question. Okay, again I am repeating, please observe. Actually, we have a material, and in this material there will be a small air gap. With this material there will be a small air gap. The flux density in the air gap is 1 Tesla with some MMF, with some ampere turn. Okay, when the relative permeability of the material is infinite. Now again the material is being changed without changing the total length and everything. Only the material permeability is changed to 1000. Relative permeability of the material changes to 1000. Under that condition you need to find the flux set up in the core, in the air gap of the this core. Okay, hello Shubham. Now please observe. All of you are aware that flux density is flux upon area of cross section of core. There is no change in the area of cross section of core. This suggests that flux density is proportional to phi, and phi is MMF, that is ampere turn upon reluctance. So since there is no change in the MMF, so you can say flux is proportional to reluctance. Flux is proportional to reluctance. So flux density is proportional to phi, and phi is inversely proportional to reluctance because of the same ampere turn. Given MMF, that is ampere turn, to be constant. So this is already highlighted that ampere turn is constant. Is it okay? Yes, sir. Now please observe. The mean length of the core is already given. So this mean length of the core is including this 0.2 centimeter. Is it okay? If you observe from here to here it is 10, from here to here it is 10, then again this is 10 and this is 10. So it including this air gap. Mean length of the core including air gap is 40 centimeter. Is it okay? Yes, sir. So when you can first take the case when material permeability is infinite. When material permeability is infinite, since reluctance is L upon mu into A, where mu is mu naught into mu r into A. Yes, sir. So reluctance in first case when the relative permeability of the material is infinite is LC upon mu naught into mu r into A plus of Lg. What is Lg? I am considering that air gap length as Lg and length of the material as Lc. Length of the material I am saying as a core. So length of the material as Lc. So Lg upon mu naught into A, because we are considering the air. For air relative permeability we treat it as 1. Further, since mu r is infinite in the first case, so this will become 0 plus of 0.2, it's in centimeter converted into meter, upon mu naught into A, where A is the area of cross section of the core. Further again, if you observe, when material is changed such that relative permeability of the material will become 1000. With the same MMF, what is the flux density in the air gap? So reluctance in this case will become Lc upon mu naught into mu r into A plus of Lg upon mu naught into mu r. Mu r is 1 into A. Okay. What is Lc? Length of the core. Total length is 40 centimeter, mean core length. So 40 minus 0.2, this will become 39.8. 0.2 centimeter I have subtracted from here. Upon mu r is 1000 plus of Lg is 0.2, and both will have in centimeters, so convert it into meters. You can multiply it by 10 to the power of minus 2. This is also 0.2 into 10 to the power of minus 2 in meters. Upon 1 you can take common as 1 upon mu naught into A, because this value is in both. Okay. So now we have reluctance in the next case also. 39.8 by 1000 plus of 0.2. So this is 0.2398 times of mu naught into A, 10 to the power of minus 2. So now we have reluctances in both the cases when material permeability is infinite and when material permeability is taken as 1000. Now we can find the flux density. Since flux density is inversely proportional to reluctance, so flux density in the air gap in second case upon flux density in the air gap in first case will become reluctance in second case by reluctance in first case. So reluctance in first case is 0.2 into 10 to the power of minus 2 upon this mu naught A, and mu naught A will get cancelled out in the ratio. Yes, sir. So 0.2398 into 10 to the power of minus 2. Can we represent like this? Rest of the thing will get cancelled out. Yes, sir. So divided by 0.2 divided by answer 0.8340. Flux density in the air gap in second case when the material relative permeability is 1000 is 0.8340 into 1. Previous flux density is 1 Tesla, so this will be 0.834 Tesla. Hoping all of you are able to understand this question perfectly. You have to round off up to the 3 decimal digits, so 0.834. How many of you able to understand this question perfectly? How many of you able to understand this question perfectly? Already, these relations are very helpful for solving the questions based on the basic magnetic circuit. Let's move to the next question. Please observe this one. I need answer from your side. So if the question is very easy, I need answer from your side. Okay. If an ideal transformer has an inductive load element at port 2 shown in figure below, the equivalent inductance at port 1 is. So sir, inductance, reactance, resistance, everything is same, sir. And we know that transformer operates at same frequency, so you can just refer it like a impedance or a resistance. So port 1 L dash will become L times of, you are shifting it to N side, so this will be N square L. How many of you able to understand this question perfectly? Great, sir. Let's talk about this one. The following figure shows a connection of an ideal transformer with a primary to secondary turn ratio of 1:100. So 1:100. The applied primary voltage is 100 volt RMS, 50 Hz AC. RMS value of the current I in ampere is. You have to find this current I. Okay, in amperes. So you know about the electrical equivalent model. We can refer this to this side. Yes, sir. When we refer this to this side, this will become current I will become 100 divided by, we are interested in magnitude, so root over of this side 80 by 100 square. So 80 by 100 square means 80 by 100 square. 80, it is 80 kilo ohm, I think. Let me verify. It's 80 kilo ohm. Yes. Kindly do the correction here, beta. I'm very sorry for this misprint. It's 80 kilo ohm. So 80 kilo ohm, when you refer to this side, this will become 80 into 10 to the power of 3 and 4. So 8. 8 square plus of. Please remember here this is XC. So always represent minus JXC. So minus JXC means basically this is minus 40 J kilo ohms. When you refer this side, it will be 4 minus of 4 plus of 10. So 6 square. We have 100 upon root over of 10. So 10 ampere. It's a very easy one. Hoping all of you have done correctly. No one have answered. Okay, great. Why, beta? Is there any problem with this? See, whenever we are referring the impedances, we need to multiply by A square, where A is the side which we are going, that side is number of turns in the numerator, and from the side we are going, that side number of turns in the denominator. So actually I have just substituted this like reactance and a resistance and a capacitance. Okay, we have 100 volt here. This is J10 ohm. Always represent the reactances in terms of J. Capacitive reactances must be represented as a minus of JXC. So this 80 multiplied by 1 upon 100 square. So that is 8 ohm only. RL dash. Similarly, minus of JXC dash will become minus of J4 ohm. All of you are able to understand this part perfectly? Great, sir. Mamu is saying that, sir, transformer ka chapter khajana dekh ke. Great, great. Please observe this one. Please observe this one. The following arrangement consists of an ideal transformer with a attenuator which attenuates by a factor of 0.8. An AC voltage VWX1 100 volt is applied across WX to get an open circuit voltage VYZ2 of VYZ2 equals to 100 volt is applied across YZ to get an open circuit voltage VWX2 across WX. Then VYZ1 by VWX1 and VWX2 by VYZ2 are respectively. See, VYZ1, I think it is missing here. VYZ1 is missing. Okay. Now please observe. Actually, in this question, see, my typist is great. So some little bit issues are there, but no issue. Please observe here. The following arrangement consists an ideal transformer and an attenuator which attenuates by a factor of 0.8. An AC voltage VWX1 is equals to 100 volt across WX. So when a voltage of 100 volt is applied here, that is called as VWX1, 100 volt, then the open circuit voltage obtained here is represented by VYZ2. And when VYZ1 100 volt is applied across YZ, so if the voltage is applied across here as VYZ1, then voltage obtained, open circuit voltage obtained across WX is VWX2. You need to find the ratio of VYZ1 upon VWX1 and VWX2 by VYZ2. Now please observe. When 100 volts is applied across VWX1. So when 100 volt is applied across VWX1, please observe, please observe. This is 1:1.25 turn ratio, and we have an attenuator. An attenuator can only attenuate, it looks like a potentiometer, okay? And voltage here is VYZ2. VYZ1. This must be VYZ1 and this must be VYZ2. Okay, yes, this must be VYZ1. So voltage appeared across here is VYZ1. VWX1 will be equals to 100 volt. This is the first case. An attenuator may have the resistance, let us suppose R2, R1 and R2. You can represent like R1 and R2. So the voltage appeared across this part when it is open circuited will be equals to VAB. VAB will be equals to 1.25 times of 100 volt. That is 125 volts. I am just referring this side voltage to this side. Okay. Then VYZ1 will become R2 upon R1 plus R2 into VAB by voltage division rule. and this attenuation factor beta is given to you, where beta is called as an attenuation factor as 0.8 times of 125. That will be again 100 volts only. So when you are applying here 100 volts, you are getting open circuit voltage across YZ as 100 volts. Is it okay? Yes, sir. In the second case, please observe. It's a very important question. Please observe. In the second case, when VYZ2 is 100 volt is applied here. So when 100 volts is applied across VYZ2, please observe here. You are applying 100 volts. VWX2, you need to identify 1:1.25. Now please observe, when this is open circuit, it means current here is a 0. When the current here is 0, current here is 0. When current here is 0, it means there is no voltage drop across this. Drop is a 0. This is your R1, this is your R2 and R1. So when drop across R2 is 0, the same voltage will be appeared across the terminal AB. Yes, sir. So voltage across AB in second case will be appeared as VYZ2 only, that is 100 volt. Why? Because it's an open circuit, so there is no current. If there is a current, there will be a drop. Then you can say, sir, we have this voltage minus this drop will be the voltage appeared across AB. But since it's open circuit, if this is open circuit, no current will flow here also. It's ideal transformer. So it means VYZ2 same will be appeared across this because there is no drop. No current, it means no drops. Yes, sir. Under this condition, when you refer this to this side, VWX2 will become 100 into A, where A is the side which you are going, that side number of turns from the side you are going, divided by that side number of turns. Okay. So 100 by 1.25 is 80 volts. So which one is correct? If there is any issue, please let me know by writing in the comment section. If there is any issue, please let me know by writing in the comment section. 100 by 100. However, the second one is VWX2. VWX2 upon VYZ2 is 80 by 100. So your correct answer is 100 by 100 and 80 by 100. That is option number B. How many of you able to understand this question perfectly? It's a very good question. See, it's the concept of open circuit. At the same time, you have to understand that there will be no voltage drop across the resistor. So basic network. Great, sir. Let's talk about this question. A single phase transformer has a turn ratio of 1:2 and is connected to a purely resistive load as shown in figure. The magnetizing current drawn is 1 ampere, secondary current is 1 ampere. If the core losses and leakage reactances are neglected, primary current is. So what is your primary current? By MMF balance, we all know primary current is I0 plus of I2 dash. Yes, sir. I0 is, sir, I0 is IC plus IM plus of I2 dash. I2 dash is 1 ampere because it's a resistive. So whatever voltage you are going to apply here, same voltage will be appear here. Okay. Yes, sir, because there is no winding resistances or reactances. So if the voltage appeared here is V at an angle 0, then voltage appeared here will be 2V at an angle 0. That shows that current is in phase with the voltage, primary or secondary, both sides. So you can represent 1, when you refer this to this side, it will become 1 by 2 divided by A at an angle 0. And magnetizing current lags 90 degree by the voltage. Core loss component of current is 0. This will be your V at an angle 0 divided by 𝐿𝐴𝑥𝑚. So 𝐿𝐴𝑥𝑚 is nothing but it is at 90 degree and 1 ampere current is given to you. So plus of 1 by 2, 2 at an angle 0. So 2 at an angle 0 plus 1 at an angle minus 90. Basically it is 2 minus J1. 2 minus J1. So root over of 4 plus 1, that is root over of 5, 2.24 ampere. Hoping all of you are able to understand this question perfectly. Great, sir. Let's talk about one more question. It's based upon the current transformer. Basically, it's a common data question. So there are two parts of this question. Okay. So only one part is here. Okay. We will talk about both of the parts. Okay. Please observe here. The circuit shows a two-winding lossless transformer with no leakage flux excited from a current source IT whose waveform is also shown. The transformer has a magnetizing inductance of 400 by pi millihenry. I'm unable to see the now. Okay. The transformer has a magnetizing inductance of 400 by pi millihenry. Peak voltage across AB with the switch S open is. So in case if this switch S is open, then what is the peak voltage across AB? See, one thing is very important. The most important precaution in case of current transformer, because it is excited by the current source, it's a current transformer. The most important precaution for current transformer is it should be not open circuited under any circumstances. Otherwise, your current transformer may get damaged. But they have made a question like this. A current of that much of ampere is being supplied of having triangular wave shape. Then during open circuited, what is the peak voltage across AB? Okay. Yes, sir. We all know that current transformer electrical model can be represented like this. Sir, RC, XM, magnetizing branch. Yes, sir. And reactance, resistance. Yes, sir. See, in case if the current transformer is open circuited, then entire current will become a magnetizing current. And transformer core may goes into the deep saturation, therefore your transformer may get damaged. That is why important precaution for current transformer is it should be not open circuited. But they have created a question. Now please observe here, just to confuse you. Sir, when we refer from this current source from this side to this side, because it is 1:1 ratio, so your same current is being transferred to this side. Yes, sir. Now when you transfer this current to this side, then R1 is 0, X1 is 0, R2, X2 is 0, R1 dash is 0, X1 dash is 0, X2 is 0, as well as your R2 dash, R2 is a 0. You need to find the voltage across this AB when the switch S is open circuited. So switch S is open circuited and we have this 30 ohm. Because 1:1, so same current is being referred on this side. Magnetizing inductance is given to you. The value of magnetizing inductance is 400 by pi millihenry. 400 by pi millihenry. Is it okay? Yes, sir. entire current will become a magnetizing current only. So voltage across AB is the same as the voltage drop across this inductor. Voltage across this inductor is, since the current is changing with respect to time, so when a current flowing through the inductor changes with respect to time, there will be a voltage drop across the inductor, that is called as a reactance voltage, L di by dt. So L is your mutual inductance given to you as 400 by pi millihenry, and di by dt is the slope of this. So if you observe, this is 10 ampere and minus 10 ampere, mentioned here as 10 ampere and 10 ampere. Okay, so what is the slope of this? Slope di by dt will become, sir, 10 minus 0 upon 5 minus 0, 5 by 10. So that is 2. y2 minus y1 upon x2 minus x1. We can find the slope. So this will become, sir, di by dt is equals to 2 millihenry. And it is in millisecond. Millisecond means so 2 into 10 to the power of 3 because of millisecond. 3 and 3 will get cancelled out. 800 by pi volts. So voltage across AB, peak voltage across AB with switch S open is 800 by pi volts. How many of you able to understand this question perfectly? How many of you able to understand this question perfectly? There is one more part. When IT is changed to 100 sine 10 sine 100 pi t, okay, 10 sine 100 pi t, then peak voltage across AB with switch closed is, it's the second part of the question. Okay, basically that part is not typed, so I'm just putting it here. In the same question, in case if IT is changed to 10 sine 100 pi t, then peak voltage across AB with switch S closed is. Now, since we are using 1:1 ratio transformer, so the electrical model will remain same. Yes, sir, the electrical model will remain same. And now the switch S is closed. So when switch S is closed, 30 ohm is connected like this. And this is your J2 pi F Lm. Okay. Or you can write omega, J omega X, J omega Lm. I can represent like this. This is your JXM. Current source IT. What is the peak current? Peak current here is 10 ampere. What is the peak current? 10 ampere. What is the value of omega? Im sine omega t as 10 sine 100 pi t. So omega is equals to 100 pi and your Im is equals to 10. So peak current we have, that is 10 ampere. Yes, sir. So what is your JXM? JXM will become J 100 pi into 400 by pi milli. So you can multiply by this. So that will be J 40 ohm. Now we have Xm as J40 ohm. So this is your J40 ohm with a frequency of, with a omega of 100 pi. Now for a peak current here, when the peak current is available here, then only there will be a peak voltage across AB. Because peak current multiplied by impedance is your peak voltage. So what is peak voltage? Peak voltage across AB. You can either calculate the peak voltage by current here, or you can calculate it peak voltage by the current here. So what is the peak voltage across AB with the switch S closed? Is peak voltage is 8 ampere into, we can use current division rule. So this will become J40 upon J40 plus 30. I am interested in magnitude only. Or you can say, sir, this will be the current. Current multiplied by 30 is your current multiplied by 30, that is resistance, is your voltage across AB. So this will become J40 40I plus of 30 40I divided by answer, okay, into 8. So in magnitude it is 6.4. This is 10, huh? This is 10. 40I this will become in magnitude 8 into 30, that is 240 volts. So I'm interested in magnitude. You can take the magnitude of this, and magnitude of this will be multiplied by 30. Okay, how many of you able to understand? But there is a contradiction. What is the contradiction? Since it's in a parallel, so voltages must be equal. Okay, in the parallel voltages must be equal, and they are, if we closely observe, then voltages are being time displayed. It seems like a voltages are being time displaced if we consider the phase also. But in case if you have to mark, you have to mark as 240 only as a correct answer for this particular question. Is it okay? Yes, yes. Hoping all of you are able to understand this question perfectly. Yes, sir. Let's talk about next question. In a single phase transformer, the total iron loss is 2500 watt at nominal voltage of 440 volt. At a frequency of 50 hertz, the total iron loss is 850 watt at 220 volt 25 hertz. Then at nominal voltage and frequency, hysteresis and eddy current losses are. First of all, you need to find Ke dash. First of all, you need to find whether V by F ratio is constant or not. So V by F ratio, you can check. V by F ratio 440 by 50 and 220 by 25. V by F ratio is constant. V by F ratio is constant. First of all, we need to check V by F ratio. So both voltage and frequencies are half. It means V by F ratio is constant. When V by F ratio is constant, then you can directly calculate Ke dash as PT1 minus PT1 by F1 minus PT2 by F2 upon F1 minus F2. Hoping all of you are able to recall this. What is total loss? Total loss is 2500 watt at 50 hertz minus new total loss is 850 watt at 25 hertz upon 25. Once you are able to find Ke dash, then you can easily find eddy current loss. Eddy current loss at 50 hertz, Ke dash into F square, F1 square. Ke dash, if you calculate this, then Ke dash into 50 square. Once you have eddy current loss, hysteresis loss will become total loss minus eddy current loss. That is at 50 hertz. Okay. Yes, sir. 2500 by 50 850 by 25. 0.64. So 0.64 into 50 square, 1600 watts. Total is 2500 minus 1600, 900 watts. So eddy current loss is 1600 and hysteresis loss is 900. How many of you able to understand? Can you do this kind of question? Please let me know by writing in the comment section. Can you do this kind of question? Great. Let's talk about one more question. The load shown in the figure absorbs 4 kilowatt at 0.89 power factor lagging. So this load is going to absorb 4 kilowatt at 0.89 lagging. Okay. Yes, sir. Further, assuming the transformer to be ideal, the value of reactance X to improve the input power factor to unity is. So, if the transformer is ideal, whatever voltage appeared here, same voltage will be appeared here. Let us suppose this is your voltage 110. It is given that voltage V2 is 110 volt. If we take it as a reference, if we take this voltage as a reference, then V1 is also 110 by 2 at an angle 0 only. Is it okay? Yes, sir. The two induced DMFs are always in same phase. Terminals may or may not be in same phase. It means like this terminal and this terminal are in phase. However, this terminal and this terminal are 180-degree displaced. Terminal voltages may or may not be in same phase, but induced DMFs are always in same phase. Is it okay? Yes, sir. So, the same voltage will be available here. If the voltage and current are in same phase at this point, then there is a resistance. So this shows that input power is remain at unity power factor only. Yes, sir. Now please observe. Can we calculate this I2 dash? I2. If you are able to calculate I2, you can calculate I2 dash. I2 dash and this I dash. The phasor sum of these two must have a zero. Must have angle 0. Then only your I and this voltage V1 will be in same phase, and then you can say that the transformer input power factor will become unity. Yes, sir. So now please observe here. First of all, we need to calculate I2 dash. What is I2 dash? I2 dash will become, sir, 4 kilowatt VI cos phi divided by 110. Yes, sir. Cos phi is 0.89 at an angle of minus of cos inverse 0.89. So this is your I2. Once you have I2, you can calculate I2 dash. I2 dash will be divided by 2 further. So 4 into 10 to the power of 3 divided by 2 into 110 into 0.89 angle minus of cos inverse 0.89. Yes, sir. So 4 kilowatt divided by 2 divided by 110, 89. So we have 20. Yes, sir. Now please observe. If we take V as a reference, V2 as a reference, then V2 and V1 are in the same phase. Yes, sir. V1 is also in the same phase. V1 is also in the same phase and it is half. Yes, sir. Current I2 lacks voltage. Current I2 lags voltage V2 by an angle of cos inverse 0.89. Yes, sir. I2 dash is I2 by A. So this current is also lagged by this. It has two components. One component is this one and one component is this one. Yes, sir. So let it be phi 2. So one can write, sir, I2 dash cos of phi 2 and I2 dash sine of phi 2. Yes, sir. For a input power factor to be unity, your voltage V1 and current must be in same phase. It is possible in case if I dash will cancel the vertical component of I2 dash. So I dash must be a leading one. Yes, sir. So I dash must be equals to, in magnitude, I dash must be equals to, for unity power factor, I dash must be equals to I2 dash sine of phi 2. Yes, sir. So I dash must be equals to I2 dash sine of phi 2, and once you have I dash, then X will become V by I dash, and it's definitely a capacitive reactance. Okay. Yes, sir. So I2 dash we have 20.20. I2 dash we have 24 by 2 by 10. 20.42. 20.429 angle of minus cos inverse 0.89. So 20.429 sine of cos inverse 0.89. You can directly put on through the calculator like this. This will be your I dash. X will become 110 by 2 divided by 20.429. Value is sine of cos inverse 0.89. So 9.3148. 9.3148. 110 by 2. Two is to 1. Okay, it's a double. Sorry. 2 is to 1. Nah? So it is 220. Yes, sir. 2 is to 1. So 220. So 220 divided by 9.3148. 23.60. Hoping all of you are able to understand this question perfectly. 23.62 ohm. How many of you able to understand this question perfectly? I wanted to show you a path. Okay. Otherwise, you can directly write, you can put this. If you are able to understand the phasor diagram. And then you can directly calculate this value. Be careful with the voltage. I have made a mistake while writing a voltage. When we are referring this side, it will become 220 at an angle 0. Please be careful with the voltage. Okay. So when you are referred this to this side, it will be multiplied by 2. That's 2 is to 1, not 1 is to 2. I made a mistake while considering the voltage. So please be careful. How many of you able to understand up to this part? Current will be divided by A, while voltage will be multiplied by A, where A is the side which you are coming, and divided by number of turns of that side from where you are coming. Hoping all of you are able to understand up to this part. Great. Please observe this one. So I can just put it like a homework, because the same question we did, same kind of question we did, KE dash you need to find out, and then you can calculate the value. Okay. Now please observe this one. Single phase air core transformer fed from rated sinusoidal supply is operating at no load. The steady state magnetizing current drawn by the transformer from the supply will have the waveform. So please observe, for a air core transformer, magnetization curve is linear. For a air core transformer, magnetization curve is linear. For a air core transformer, magnetization curve is linear. Yes, sir. So for a linear magnetization curve, in order to produce sinusoidal flux, we need to apply, a sinusoidal magnetizing current. So in order to produce sinusoidal flux, we need to apply sinusoidal magnetizing current. So basically, single phase air core transformer fed from a rated sinusoidal supply at no load, steady state magnetizing current drawn by the transformer from the supply will have the waveform sinusoidal only. Why? Because it's a air core. In case if it is not air core transformer, then your harmonic effect will be considered. And if the supply is sinusoidal, magnetizing current is sinusoidal, but your flux changes. Okay. Yes, sir. Great. Now let's talk about one more question. The star delta transformer shown below is excited on a star side balance 4-wire 3-phase sinusoidal voltage supply at rated voltage magnitude. The transformer is under no load condition with both S1 and S2 open. Core flux waveform will be. When both are open, see, in case if there is no path for the third harmonic current, then flux is flat topped, EMF is peaky in nature, and current is sinusoidal. Because if there is no path for the third harmonic current, then your magnetizing current will remain sinusoidal only. Okay. So in a star delta transformer shown below is excited from star side with a balanced 3-phase 4-wire. The transformer is under no load condition when both S1 and S2 is open. No load condition means your load current is 0. So core flux waveform will be flat topped as no path, because both sides it's a star and it's a open delta. Star and open delta, we don't have a path for the third harmonic current. No path for third harmonic current. So flux wave form is flat topped with depressing third harmonic. So flat topped with the depressing third harmonic. How many of you able to understand up to this part? In case of non-linear waveform, will the option D? Which one, beta? Which one? You are talking for this? No. Actually, it is given a rated sinusoidal supply. So when the supply is sinusoidal, it means current is sinusoidal. Your voltage will be peaky. And if we talk about onto the secondary side, here it is on no load, so there is no secondary side current. But in case if the secondary side current is present, then peaky induced EMF causes third harmonic current, and that will get path through the load in case of a single phase transformer. So when the third harmonic current will start flowing, then your secondary current will become peaky, and your primary current, because through the MMF balance, your primary current also get distorted to peaky. Okay. So that is the case when the load is connected. When the load is not connected, under that condition there is no current, no path for the third harmonic current from the secondary side. So voltage will remain peaky only. Hoping you are able to understand this. Great, sir. Now let's talk about this one. A 3-phase 3-winding delta star transformer is energized from AC mains at 1.1 kV side. So it's a basically three winding three phase transformer. It supplies 900 kVA load at 0.8 power factor lag from 66 kV winding and 300 kVA load at 0.8 power factor lag from 400 volt winding. The RMS line current in ampere drawn by 1.1 kV winding from the mains is, great sir. Please observe here. We have a delta star connection. Delta star connection. Yes sir. So we have three winding transformers. Three winding transformers, and they are connected in delta and star. The total load supplied from the source is equals to total load demanded by the loads. Let the load be secondary and tertiary, and from the source kVA is input kVA is S1. So what is the load supplied by the secondary? I am treating this as a secondary. So 900 kVA load, 900 kVA load at a power factor of 0.8 lag. Yes sir. Another transformer is of 400 volt winding. This one I am treating as a tertiary, 300 kVA at a power factor of 0.6 lag. Yes sir. This will be equal to input kVA. Input side is 1.1 into 10 to the power of 3, that is V1. Phase voltage and line voltage is same on delta side. So V1 I1. Phase voltage and line voltage is same on delta side. Induced EMFs are always in same phase. Yes sir. So let's talk about phase voltage V1 I1. So first take the input kVA. Input kVA is your root 3 times of Vi. So this will give you the value of current, line current from the primary side, because it's a 3-phase transformer and it's a total kVA supplied. So total kVA supplied will become 900 at an angle of plus of cos inverse plus only, plus of cos inverse 0.8 plus of 300 at an angle of plus of cos inverse 0.6. So we have 1109.724 magnitude wise. If we talk about magnitude wise 1109.724 divided by root 3 divided by line voltage is your 1.1 kV, so 1100. .78 ampere. Please let me know by writing in the comment section. Are you able to understand? Sir, yes, I have substituted positive only. How many of you are able to understand this question perfectly? How many of you able to understand this question perfectly? Please let me know by writing in the comment section. I have made somewhere some mistake. I did some mistake. Input kVA is okay. (900 kVA 0.8 power factor lag and 300 kVA 0.6 power factor lag. So input kVA will be equals to I did some calculation mistake. I did some calculation mistake. 1190.96 at an angle of 40.91. Now magnitude of this will be √3 VI, where this is line current and line voltage. So your line current will become 1190.96 divided by √3 times of line voltage 1.3. This is also in kV, this is also in kV. Okay, this is in kVA. So after solving we have 625.09. In case if the power factor is also being asked, you can calculate along with the angle. You will have a power factor of 40.91. So cos of 40.91 lagging. Okay, that will be the power factor. So 625 ampere. Kindly check the calculation once. How many of you able to understand up to this part? You need to check the calculation. Beta, I did mistake while putting onto the calculator. So please be careful with the calculation. Great. Please observe this one. Please observe this one. A single phase 22 kV 2200 by 220 volt 50 hertz distribution transformer is to be connected as an auto transformer to get an output voltage of 2420 volt. Its maximum kVA capacity is, so auto transformer maximum kVA will be A auto upon A auto, A auto upon A auto minus 1 into kVA of two winding transformer. Whenever a two winding transformer will be connected as an auto transformer, where A auto must be close to unity. So these two will be added. Yes, sir. So it's additive polarity divided by higher of the secondary. Higher of the two winding transformer will be a secondary of auto transformer. Then only A auto will be close to unity. Okay. Divided by 2420 by 2200 minus 1 into kVA of two winding transformer 22. So 2420 divided by 220 into 22. 220 kVA. 242 kVA. 11 times. 242 kVA. How many of you able to understand this question perfectly? Please let me know by writing in the comment section. Great, sir. Let's talk about one more question. A 200 by 400 volt 50 hertz two winding transformer is rated at 20 kVA. The windings are connected in as an auto transformer of rating 200 by 600 volt. A resistive load of 12 ohm is connected on high voltage 600 volt side auto transformer side of the auto transformer. The value of equivalent load resistance seen from the low voltage side is. So we have an auto transformer here. This auto transformer is of 200 by 600 volt, or you can represent like this. Two winding transformer is 200 by 400, rated 20 kV. Its windings are reconnected as an auto transformer. Its windings are reconnected as an auto transformer. 200 by 600. Okay, so basically this is 200, this is 400, so this will become 600 volt side. Is it okay? Yes, sir. And a resistive load of 12 ohm is connected onto the 600 volt side of the auto transformer. So what is your RL dash? If this is your RL, load resistance RL, then what is your RL dash? RL dash means seen from the LV side, the value of resistance seen from the low voltage side. I need your response. I need your response. How many of you able to understand up to this part? Hmm. Let me prove to you. This will be, say, HV side, so IH current. Can you calculate this IH current? Yes, sir. So this transformer is acting as a 200 volt by 600 volt. So if we consider this as a reference, then 600 volt by R, we have IH. Once you have IH, you can calculate its additive polarity, then only your transformer will become 600. Okay, 400 and 200 must be in the additive polarity. So if you know about IH, you know about IH, it means kV on input side and kV on output side is same. So you know about IL also. When you know about IL, it means you know about V by IL, that is resistance seen from the input side. Either you can go like this. So what is your IH? If we talk about IH, this will become 600 by V by RL 12. So 50. Of course, if you consider an angle, then it is 50 at an angle 0 because of resistive load. And VLIL on input side is equals to VHIH on output side. Yes, sir, because it's ideal transformer. Nothing practicality is given. So IL will become, LV side current will become, VH is 600, this is 200, yes sir, into 50 at an angle 0. Yes sir, once you have IL, so this will become 150 at an angle 0. Now we have IL, we can calculate resistance RL dash as VL upon IL. Yes sir, so it's a resistive only because VL and VH are in the same phase, that already I have told to you. So 150 divided by, what is the value of IL here? IL will be equals to 150 and VL is 200. 200 by 150. So 200 by 150 is basically 1, 2 by 1.33 ohm. You can also calculate by multiplying A square. What is A auto? What is A auto? A auto is VH by VL. So VH by VL means 3. So RL dash can also be represented as A square times of RL, where A is, you are going to refer on to the LV side. Huh? Yes, sir. Better to write RL upon A square. So RL is 12 divided by A auto square will be 3 square 9. So 12 by 9. Yes, sir. 1.3333 ohm. You can do it either of the two. When will be the DA batch started? Beta, presently we are discussing about the electrical machine. So for your data, DA classes will be started soon. Okay. That is only I can give you update. Okay. One more question. Please observe. Two single phase transformer. How many of you are able to understand this question perfectly? You can do it in either of the way. Okay. Please try to solve this one. KVA shared by, we all know KVA shared by transformer 2 is, KVA shared by transformer 2 conjugate is SL conjugate multiplied by Z1 upon Z1 plus Z2. Hoping all of you are able to recall this. KVA shared by transformer A is ZL into ZB upon ZA plus ZB. KVA shared by transformer B is SL conjugate into ZB upon ZA plus ZB. So since here transformer T1 and T2 is mentioned, so I am representing S2 KVA shared by transformer 2 is SL conjugate into opposite one, because by the KCL I have derived this, if you remember. Okay, so opposite one, if you have to calculate for this, then opposite of this will have the impedance in the numerator. So Z1 upon Z1 plus Z2. KVA, load KVA is, because both the transformers are rated at 500 kVA, so we need not to calculate the per unit impedances on common base, because both will have already common base impedances. Both will have same kVA and voltage rating. So both are on the same base. Okay, so you need not to calculate the base again, on common base again. In case if the transformers will have different kVA, then we need to find out the common base. So the load is of 1000 kVA, cos inverse 0.8. What is Z1? 1 plus J6 upon 1 plus J6 plus 0.8 plus J4.8. You can calculate by real and imaginary part on your gate calculator. You can resolve in real and imaginary. Basically, this will become 1000 into 0.8 plus of j1000 into 0.6. Now you can calculate this one also. So I can put directly, na? 1 plus 6i plus 0.8 plus 4.8i. 1 plus 6i divided by answer multiplied by we have to put it conjugate. So this will be negative only. Now the issue with the question is the transformer is under overloaded condition. How many of you are able to this? How many of you are able to understand this? You will get a PDF of this in my Telegram at the rate Varun sir PW. Okay, you will get the PDF at the rate Varun sir PW. Telegram channel. All of you are able to understand up to this part. So it's a very easy calculation basically, because this magnitude and angle, when you are going to put, it will be simply 0.5555. Okay. Let's talk about one 3-winding transformer concept also. Please observe. A 3-winding transformer is connected to an AC source is shown in the figure. The number of turns are as follows: N1, N2, N3. If the magnetizing current is neglected, the current in the two windings I3 and I4, I2 and I3 is 2 ampere at an angle 30 and 2 ampere at an angle 150. What is the value of the current in ampere? What is the value of the current in ampere? Try everyone, try everyone. See, from MMF balance, we all know N1 I1 is equals to N2 I2 plus of N3 I3. Okay? Yes, sir. So we need to find the primary current I1. N2 we have. What is the value of N2? 50 by 100 into I2 is 2 at an angle of 30 plus N3 we have 50 by 100. What is the value of I3? 2 at an angle 150. So You can easily do the calculation for 1 at an angle 30, 1 at an angle 150, 1 at an angle 30 plus 1 at an angle 150. One at an angle 90. How many of you able to understand this part perfectly? You can also put it like this: cos 30 plus j sin 30, and this will be cos 150 plus j sin 150. Okay. So hoping all of you are able to understand this part perfectly. Let's move to the next topic. Okay. One more question and then we will move to the next topic. Please see, two three-phase transformers are realized by using single phase transformer as shown in the figure. The phase difference in degrees between V1 and V2 is. So we need to find the angle difference between V1 and V2. Please observe here. We have two transformers. One transformer is delta delta and one is your delta star. So delta delta may be 0 degree, or maybe it is 0 degree, and maybe it is 180 degree. If you observe properly, then you can easily identify that this is a case of delta delta 0 connection. So it's a delta delta 0 connection. So it's a delta delta 0 connection. It can be a delta star 1 or delta star 11. In both the cases, there will be the angle onto the V2 will become at an angle 30, and here at an angle 0. So the angle difference between these two is going to be 30 degree. Okay. Yes, sir. So answer is very easy. You will get answer as 30 degree. It will be clearly observed. But let me show you how to find the angle differences. How to find the angle differences in such kind of cases. Okay. Now please observe here. So the primary side is in delta. Primary side is in delta. Yes, sir. And secondary side is in delta, and secondary side is in star. So first of all, you have to identify which connection is the first one. Okay. So for delta delta, if you observe a delta delta connection, so in a delta delta connection, we can take a reference node and then A, B and C phase. Make a delta, consider a neutral point, take HV at 12 o'clock position, and then make a delta A2 A1, A2 A1, B2 B1 and C2 C1. A phase is brought out from A2, B phase is brought out from B2 and C phase is brought out from C2. Same neutral will again be drawn here. A2 A1 must be in parallel with A2 A1. So LV side A2 A1 must be in phase with A2 A1. So make a parallel line of A2 A1. Okay. Now observe, A1 is connected with B2. A1 is connected with B2. So we need to connect A1 with B2. And when you are going to connect A1 with B2, your B2 B1 must be parallel with B phase. Your B2 B1 must be parallel with B phase. Okay. So when we draw a line, this one, then only it looks like parallel to this one. Yes, sir. So B2 B1 B phase. Now observe here, the connection of B1 is with C2. So you need to short B1 with C2, B1 with C2, and also be careful to make parallel line with C2 C1. So this will be your C2 and C1 for parallel to this one. It can be clearly observed that C phase is brought out from C2. it can be clearly observed that from B to A, VAB, and from B to A, VAB, both the lines are in parallel. So this is your delta delta 0 connection. So this is your delta delta 0 connection. Is it okay? Yes, sir. Delta delta 0 connection. Is it okay? Yes, sir. Now let's talk about delta star. If we talk about delta star, then first always draw a star. Okay. So if you look for a star, then A to A1, B to B1, and C to C1. Can I represent like this? Yes, sir. So this will be your A to A1, B to B1, and C to C1. Let it be A phase, B phase, and a C phase. Yes, sir. And induced GMFs are in same phase, so draw a line in parallel with A to A1. This is your A phase. Now observe the connection. A2 is connected with C1 and A1 is connected with B2. So you need to connect A1 with B2 and you need to draw a line parallel to B phase. So this is the only possibility to make delta. This will be your B2 and this will be your B1. Parallel line to B phase. Same if you observe here, B1 is connected with C2. So B1 is connected with C2. B1 is connected with C2. This is the only possibility to make parallel line to the C phase. This will be your C2 and C1. Already it is given in the question itself that this is your A, B and C phase. So your line to line voltage is this one, is your capital VAB. And if you observe line to line voltage from B to A, this will be your small VAB, ABC. So when you are going to put these two onto the same line, so this is at 60 degree, however this is at 30 degree. So this shows a small VAB, when you put both onto the same reference, a small VAB here only, then a small VAB leads capital VAB by 30 degree. So this connection is a star, delta star 11. Delta star 11 connection. Okay. Yes, sir. Now if this will be your line voltage, so line voltage on this side will be, if we treat VAB as a line voltage at an angle 0, then V small AB in case of delta delta will be equals to, sir, VL dash at an angle 0. However, V small AB in case of delta star 11 will be equals to, sir, this will become VL dash at an angle plus 30. So the angle difference between these two will be 30 degree. Angle difference between these two will be plus of 30 degree. How many of you are able to understand this question perfectly? Ashutosh is asking, sir, in single line diagram, why transformer is denoted by circular form? Actually, it's a concept of link. So that is why transformers are denoted like this. Okay. It is just representing that link. There are many different symbols that we can use. Is it okay? Because in transmission line, we have to represent the reactances also, line reactances also. So one will not get confused with the reactances and a transformer. That is why it is represented by the link. I am hoping all of you are able to understand this question perfectly. Great, sir. Now let's talk about DC machine. Please observe this question. A 4-pole lap connected separately excited DC motor draws a steady state current of 40 ampere while running at 600 rpm. A good approximation for the wave shape of the current in the conductor of the motor is given by. So please observe. We need to find the good approximation of the current in the conductor. So current in First, find frequency of current in armature conductors of DC machine. Frequency of current in armature conductors of DC machine is Pn by 120, PNR by 120, where P is the number of poles, NR is the speed in RPM, and 120 is a constant. So 600 and 4 pole, so 4 into 600 by 120. So what is the frequency? Hertz. So what is the time period of the cycle? Time period of the cycle is 1 upon frequency. So 1 upon 20. 1 by 20 means 50 milliseconds. Basically it is 0.05, or you can say 50 milliseconds. It means 15 to 10 to the power of minus 3. That is 0.05 only. So time period of the cycle is 0.05. Now, we all are aware with the term commutation. We all are aware with the term commutation. During commutation, there will be a reversal of the current in the coils of a DC machine from plus of IC to minus of IC in time period of TC. Yes, sir. In time period TC, where time period TC is the period of commutation. Yes, sir. We all know that whenever the current is being shorted by the two brushes, whenever the coil undergoing commutation is shorted by the brush, under that condition the current in the coil has to reverse from plus IC to minus IC, and then it will remain same until unless again that coil will come in the until unless that coil will again goes undergoing into the commutation. Yes, sir. So what is coil current? Coil current is armature current upon number of parallel path. Armature current is 40 ampere, and since this machine is a lap connected, so number of parallel path is equals to number of poles. So 10 ampere is the coil current. We all are aware with the term commutation. What happens in the commutation, sir? Suppose if we have a commutator segment 1, 2, 3, 4, 5, so on. Okay, these are the coils. Yes, sir. And suppose if we are moving this coil along with the commutator in this direction, and we have a brush here. So all these coils will carry current IC, and all these coil currents under the influence of south will carry current IC. Now, at the instant when they are being shorted by the brush, please be careful. Since it is moving, commutator is moving and brush is remain in its position. So at this particular instant, what happens in the coil current? 1, 2, 3, 4, 5, 6. If you observe, now under the influence of north will carry current this, and this will carry current this. These two will carry current and transfer 2 IC to the load. Now if you observe, this coil is being shorted by the brush because of the two commutator segments are being shorted by the brush. This coil is being shorted by the brush. Under this condition, the current in a coil has to change from plus IC to minus IC. Only at this duration the current is going to change. So again in this particular coil, the current is going to change when it goes under the commutation. Yes, sir. So once the coil current is being changed, it will remain at the same level until unless the same coil again going to be passed through the again going to be shorted by the brush. So when we do the approximation of the current in the armature coil of the DC machine, then please observe the current is changing from plus IC to minus IC during commutation, then it will remain 10 ampere. Then again during the commutation it changes, then it will remain 10 ampere. Again during the commutation period it changes. Yes, sir. Now what is the time period of the cycle? Sir, time period depends upon the frequency, and that will be of 50 milliseconds. 50 millisecond, in 50 millisecond there will be one cycle get completed. So up to this part, this is 25 milliseconds, and this is also 25 millisecond. This current is of 10 ampere. So in one direction I am saying 10 ampere under the influence of north, and under the influence of south I am saying minus of 10 ampere. Is it okay? Yes, sir. This is also your 50 millisecond. Great, sir. Considering the linear commutation, this is the period of commutation. So in case of the linear commutation, we have the current flowing into the armature coils. A good approximation for this particular one is this one, not this one. Current is not sinusoidal. Once the current is being changed, it will remain same until unless again the coil will goes into the commutation period. Again when the coil is going into the under the commutation time. How many of you are able to understand this? A 4-pole separately excited wave wound DC machine with a negligible armature resistance is rated for 230 volt and 5 kilowatt at a speed of 1200 rpm. If the same armature coils are reconnected to form a lap winding, what is the rated voltage and power respectively at 1200 rpm of the reconnected machine if the field circuit is left unchanged? Very good. So for wave connected armature. So for wave connected armature, we know that there is only two parallel paths. It's a 4-pole machine. Let us suppose this to be north. So this voltage is 230 volts. As RA is not given, so we don't know about the drop. So I am considering EA as a terminal voltage. Okay. So for 230 volt, armature resistance is negligible. So it means your V and rated volt induced EMFs are same. So this will be your EA. In case of wave connected, so I am writing EAW as 230 volts. What is the voltage induced in the coils per pole? Voltage induced in the coil per pole is 115 volt. Is it okay? Yes, sir. So this is 115. 115. Yes, sir. So total will be equals to 230. This is the voltage induced per pole. The voltage induced per pole for a 4-pole machine we have. For a wave winding, we have total voltage to be equals to 230 volt. Yes, sir. Further, power it delivers EA into IA equals to 5 kilowatt. So we know about IA. Let it be IA. So this will be your IA by 2 and this will be your IA by 2. Yes, sir. IA in case of wave wind is IA by A, number of parallel path of wave. And when the same machine is connected as lap, so when lap connected armature, in lap connected machine, number of parallel path is equals to number of poles. Number of parallel path is equals to number of parallel poles. Number of parallel path is equals to number of poles. Yes, sir. Voltage per parallel path will become voltage in case of lap. Yes, sir. Current in case of lap. Power in case of lap. So, voltage in case of lap. Voltage in case of lap is P phi Zn upon 60A. Rest of the things are same. So you can say, sir, let me create a relation. EA is proportional to number of parallel path if all other things are constant. So EA in case of lap by EA in case of wave will become A of wave by A of lap. A of wave, number of parallel path, 1 by 2. So it means induced EMF in case of lap will become 230 by 215 volt. I am hoping all of you are able to understand this with the help of this diagram as well, because same coils are being connected as a lap. Okay. Yes, sir. What about the current? IA in case of IA, coil current is equals to armature current upon number of parallel path. This shows coil current is proportional to number of parallel path. So coil current in case of lap by coil current in case of wave will become wave by lap. Yes, sir. So coil current for same coil current, because the rating of the coil current is same. So for same coil current will remain same. So IA is proportional to A. So IA in case of lap by IA in case of wave will become A of lap by A of wave. Number of parallel path in case of lap is 4. Number of parallel path in case of wave is 2. So this shows armature current in case of lap will become twice of armature current in case of wave. What about power? Power is EA of lap into IA of lap. So EA of lap is EA of wave by 2 and IA of lap is twice of IA of wave. So this will remain power of wave is equals to power of lap. 5 kilowatt. So power is not going to change. Is it okay? See, because there is no change in the coil, so the thickness of coil is not changing. It means coil current is not changing. If you observe the coil current is IA by 2, IA by 2, IA by 2, IA by 2, because coil will have a capacity to flow IA by 2 current depending upon the thickness. So IA by 2 and IA by 2. When you add all these four current, it will become IA by 2, IA by 2, IA, twice of IA. So twice of IA with half of the voltage, power will remain 5 kilowatt. Option number A is correct. How many of you are able to understand this question? Great, sir. Let's make one more question. A 5 kilowatt 220 volt DC shunt motor has an armature resistance including brushes 0.5 ohm. Motor draws a no load current of 3 ampere. The field current is constant at 1 ampere. Assuming that the core and rotational losses are constant and independent of the load, the current drawn by the motor when delivering rated load for the best possible efficiency is great. Whenever motor draws current under no load condition, it means you know about the no load rotational losses. So basically rotational losses is armature power under no load condition, that is EA under no load into IA under no load. What is EA? EA is V minus of IA RA. Brush drop is there? No sir, brush drop is neglected, into IA no load. So we know about no load current. No load current drawn from the supply we have, and field current we know. So we can calculate armature current. Yes sir. So this will become, who is saying B beta? Okay. Yes. This is not A, this is B. Yes. I'm sorry for this. Voltage is being half. However, the kilowatt will be remain same. Voltage will be half. Kilovolt will remain same. Voltage will be half. Kilowatt will remain same. Okay. Please, such kind of errors are not allowed for GATE exam. Okay. Otherwise, it's a big mistake. Okay. Now let's come back to this. Voltage is 220 volt. Minus of IA no load 2 ampere. RA we have 0.5 into IA no load. What is IA no load? 2 ampere. We have calculated no load current IA as IL minus IF. IL minus IF. Hoping all of you are able to understand this part. Yes sir. So 220 minus 2 into 0.5 into 2. 438 watts. This is your rotational losses, which is going to be constant. It is already given in the question itself. Yes sir. Now when it delivers a rated load, so armature power under full load is output power plus rotational losses. Output power is 4. Output power is rated output power is, full load output power is 5 kilowatt plus 438. So 438 watts. What is armature power? Armature power is EA under full load condition into IA under full load condition. Yes sir. So EA into IA under full load condition is 438 watts, and EA is V minus of IA full load into RA into IA full load, 438. So now we have a quadratic equation, 220 into IA full load minus IA full load, we have the square of this RA is 0.5. So 0.5 IA full load is square minus 438 is equals to 0. From here we can calculate IA full load. Once we are able to calculate IA full load, then current drawn by the motor, line current will become armature current plus field current. Field current is fixed as 1 ampere, so you can easily calculate. Only we need to solve this quadratic equation. So minus of 0.5, then plus of 220, minus of 5438. So we get two values, 413.711, another value is 26.28. So we discard this value and select this value for best possible efficiency we need to choose the lower value, because if we choose the lower value, then only your input power and output power difference will be lower and your efficiency will be higher. Okay, so you have to discard the higher value and select lower value for a best possible efficiency. Now 26.28 plus 1, so this will be 27.28 ampere. Be very careful. The current drawn by the motor while delivering rated load for the best possible efficiency is, yes, 27.28 ampere. How many of you are able to understand up to this part perfectly? Okay, please try this question. Please try this question. Yes, GATE favorite topic. See, separately excited motor has an armature resistance of 0.05. Field excitation is constant. Armature voltage is 100 volt. Motor produces a torque of 500 Newton meter at zero speed. Motor produces a torque of 500 Newton meter at 0 speed. Neglecting all mechanical losses, the no load speed of the motor for an armature voltage of 150 volt is. Armature, the motor produces torque of 500 Newton meter at 0 speed. Neglecting all the mechanical losses, the no load speed of the motor in radian per second for an armature voltage of 150 volts. See, we all know what is torque. Torque is defined as K dash phi into IA. Yes, sir. Now, torque is given to you, and at an armature voltage of 100 volts at 0 speed. So at 0 speed, EA is equals to 0. When EA is equals to 0, armature current will become V minus EA by RA. It means V by RA. V by RA is your 100 by RA is 0.05. So now we have IA. If you have IA, you can find K dash phi. K dash phi will be torque upon IA. Torque is 500 Newton meter upon IA. 100. 0.05. .25. Is it okay? If you have any doubt, please let me know by writing in the comment section. So, once you have k dash phi, you can calculate omega. Omega is V by k dash phi. No load speed. IA under no load condition is 0, as rotational losses are neglected. If you don't able to calculate the values from the given data, then also you have to consider it as neglected, because we can't calculate no load, we can't calculate rotational losses, no load losses or rotational losses. So from here you can say, sir, already it is given also, neglect all mechanical losses. So that means no load current is 0. When rotational losses are 0, motor will not take any current. So omega m will become, under no load condition, EA is equals to V minus IA RA. Under no load condition, if this is 0, then EA is equals to V, and EA is k dash phi omega m under no load condition is equals to V. Omega m under no load condition will become 220 100 volt, 100 by 0.25. 400 radian per second. How many of you are, oh great, it is not 100, the voltage is being changed to 150 volt. However, the rest of the things will remain unchanged. 150 by 0.25, 600 radian per second. So your answer is 600 radian per second. How many of you are able to understand up to this part? Yes, yes, yes. Great, sir. I'm also highlighting what are the possibilities of errors. Please observe here, 120 volt DC shunt motor takes 2 ampere at no load and takes 7 amperes at full load while running at 1200 RPM. Armature resistance is 0.8 ohm. Shunt field resistance is 240 ohm. The no load speed in RPM is, so no load by full load speed is equals to V minus IA no load into RA upon V minus IA full load into RA. If there is a change in the flux, we will consider as full load by no load. But armature reaction is neglected, so there is no change in the flux. Full load speed is, on full load it is running at 1200 RPM. Voltage 120 volt. Current on no load it takes 2 ampere, but field winding resistance is given and voltage is 120 volt. So 120 by 240.5 ampere is your field current, and load current minus field current 1.5 ampere. RA we have 0.8 divided by 120 minus 6.5 into RA 0.8. Now you can do the calculation for the no load speed. How many of you are able to understand? Great, sir. Is it okay? Yes. Now let's talk about a question based on the braking of induction machine and from the characteristic also. See, a separately excited DC motor runs at 1500 RPM under no load with a 200 volt applied to the armature. The field voltage is maintained at its rated value. Motor speed of the motor when delivers a torque of 5 Newton meter at 1400 rpm as shown in the figure. Rotational losses and armature reactions are neglected. Motor to deliver a torque of 2.5 Newton meter at 1400 rpm. The armature voltage to be applied is. How much armature voltage need to be applied if the motor has to produce 2.5 Newton meter at 1400 rpm? See, from the torque speed curve, it is already mentioned that onto the zero speed machine is running at 1500 rpm, and when it produces a torque of 5 Newton meter, its speed is reduces to 1400 rpm. Yes, sir. We have a shunt machine, separately excited machine. We have a separately excited machine here. Under no load condition with a 200 volts, under no load condition with a 200 volts, motor is running at 1500 rpm. Yes, sir. Field voltage is maintained at its rated value. It means there is no change in the field current, so there is no change in the field flux. Armature reaction is also neglected, so there is no change in the field flux. Yes, sir. When it delivers a torque of 5 Newton meter, motor speed is reducing. Yes, sir. Rotational losses and armature reactions are neglected. Motor to deliver a torque of 2.5 Newton meter at 1400 rpm. Armature voltage applied is. First of all, we need to calculate the value of armature resistance. Then only we can do the calculation of EA plus IEA-RA. Okay, that will be the voltage needed to be applied in order to rotate 1400 rpm while producing a torque of 2.5 Newton meter. So please observe. Under no load condition, since rotational losses are neglected, so IE under no load is 0. EA1 is equals to V is equals to 200 volts at 1500 rpm. We all know that induced EMF depends upon the speed. While producing a torque of 5 Newton meter, it rotates at 1400 rpm. So, at a torque of 5 Newton meter, speed is 1400 rpm. So, induced EMF is K dash phi omega m or K phi n. From here you can say there is no change in the flux, so EA is proportional to n. So new induced EMF will become 1400 by 1500 into 200. It depends upon the speed. Yes, sir. Now, you know about EA2. Yes, sir. Torque is given to you at a torque of 500 Newton meter. So it means we know about armature current as well. So, what is armature current? IA will become EA2 V minus EA2 by RA. Yes, sir. So 200 minus whatever value is coming here by RA. But we don't have RA. IA can be calculated from torque expression as well. So torque is K dash phi into IA and K dash phi will become K dash phi is torque upon Ia, or you can write EA by omega m. So it can be calculated from no load as well. So 200 divided by 2 pi into n, 1500 by 60. What is the value of current Ia now? Torque of 500 Newton meter, 5 Newton meter upon 2 pi, 200 into 60, 2 pi into 1500. Yes, sir. So 2 pi into 1500 into 5 by 200 divided by 60. 3.926 ampere. This is your armature current when producing a torque of 5 Newton meter. So current when producing torque of 5 Newton meter, 1400 by 1500 into 200. This is 186.67 volts. Yes, sir. So now we know about the armature current. From armature current, you can calculate armature resistance as well. EA2 minus V minus EA2 upon IA. So 200 minus 186.67 upon 3.926. What is the value of RA? Minus answer by 3.926. 3.34 ohm. 3.4 ohm. Approximately 3.39, so it is 3.4 ohm. Now we have RA. When running at 1400 RPM and torque of 2.5 Newton meter. So EA3, third case, will remain EA2, that is equals to 186.67 volts, because it depends upon voltage. It depends upon speed and flux. Flux is constant and speed is 1400 previously as well as now. So at 1400 RPM, this machine will have 186.67. In order to produce a torque of 2.5 Newton meter, what is the current drawn by the machine? Machine is same. So torque 2.5 Newton meter is K dash phi into IA. You can calculate new IA3 value. So this is 2.5 multiplied by K dash phi is 200 by 200 into 60 by 2 pi into 1500. So this will be multiplied with a torque 200, 2 pi into 1500, 2 pi into 1500 divided by 2 into 60. This is a machine constant. So machine constant is not going to change. It's a machine constant. Machine constant is not going to be changed. Okay. Yes, sir. So 2 pi into 1500 into 2.5 divided by 200 divided by 60. New current is 1.9634 ampere, and your voltage needed will be equals to EA plus of IA. RA, EA is 186.67 plus of 1.9634, RA 3.4. So this will become 186.67. 193.34 volts. How many of you are able to understand this question perfectly? Actually, it's a two question, combination of two question, but I have created in a single one, so that you will have a more to think how to calculate the value of RA and how to calculate the value of terminal voltage. Very good. Great, sir. Let's talk about one question based on the braking also. A 250 volt TC shunt motor draws 15 ampere while supplying rated load at a speed of 80 radian per second. The armature resistance is 0.5 ohm and the field winding resistance is 80 ohm. Net voltage across the armature resistance at the time of plugging is. So we have field winding of the shunt machine. What is field winding resistance? 80 ohm. Terminal voltage applied will be 240 volts. And RA is 0.5 ohm. Machine is taking a current of 15 ampere while running at 80 radian per second. So machine is taking a load current of 15 ampere. You can calculate field current 240 by 80, 3 ampere. So you know about the armature current as well. That is 12 ampere by KCL at this point. Induced EMF is V minus of IARA 240 minus of 12 into RA 0.5. That will become 234 volts. And at the instant of plugging, armature terminal is reversed. So if we have A2 A1 terminal, then terminal A2 A1 got reversed. Whenever we have to brake, whenever we have to apply brakes onto the DC machine, we can either use regenerative braking, dynamic braking, or a plugging. In a case of plugging, armature terminals are being reversed. However, at the instant of plugging, the speed of rotation will remain same and the direction of rotation will remain same. It means polarity of induced EMF will remain same. A2 is with a positive polarity and A1 is with a negative polarity. So this will remain same. Voltage applied will be 240 volts. Yes, sir. What is the voltage appeared across the armature resistance? Voltage appeared across the armature resistance is plugging voltage. Plugging voltage will be equals to, sir, it can be clearly observed the voltage appeared here, V plus EA. So 240 plus 234, 474 volts. So this is the voltage appeared across the armature resistance. This voltage is very high, so that will create a very high current. So while plugging, we need to use the external resistance to limit the current. Second part is for that part. Please observe the external resistance to be added in series with the armature circuit to limit the armature current to 125% of its rated value. Current IA can write, sir, V plus of EA is equals to IA RA plus R external. But the current has to be limited to 125% of the rated value. 474 is the plugging voltage at the instant of plugging. RA we have 0.5. R external we don't know. This value should not be more than 125% of the rated value. Rated current already we have calculated as 12 ampere. Then our external value will become 474 by 12 by 1.25 minus 0.5, 31.1 ohm. So if we put this resistance, how many of you are able to understand? Motor behave as a generator? No. Motor is not behaving as a generator. Motor will draw very high current, and there is a very massive copper loss at the instant of plugging. That is why plugging is not suggestible for the high inertia loads. For a high inertia load, regenerative braking will be more preferable. Is it okay? Yes, sir. Let's talk about some questions based on the induction machine. So a 3-phase 4-pole 400 volt squirrel cage induction motor is operating at a slip of 0.02. The speed of the rotor flux in mechanical radian per second sensed by the stationary observer is close to. See, what is the must condition for production of steady state electromagnetic torque? Relative speed between stator field and rotor field must be 0. So in a squirrel cage induction motor, we need to find the speed of rotor flux with respect to stator body. So speed of a rotor flux with respect to stator body is the speed of rotor flux sensed by the stationary observer. Yes, sir. So speed of rotor flux with respect to stator body is ns only. Ns only in terms of radian per second, omega sm only. That is 2 pi ns by 60, 4 pi f by p. So 4 pi f is 50 hertz and number of poles are 4. So 50 pi is 157 radian per second. How many of you are able to understand this question perfectly? See, motor will operate only if the relative speed between stator and rotor field is 0. On any body, if you are observing onto the stator body or if you are observing onto the rotor body. Since it's a squirrel cage induction motor, so definitely supplies onto the stator side. Stator field with respect to stator body is running at a speed of ns, or you can say omega sm, synchronous speed in radian per second. Then rotor flux with respect to stator body must be equals to ns only. Okay? Yes, sir. Now let's talk about one more question. A 3-phase 400 volt 6-pole 50 Hz squirrel cage induction motor is running at a slip of 5%. Speed of stator magnetic field with respect to rotor magnetic field and speed of rotor with respect to stator magnetic field are. Now please observe. Consider this to be the stator. Okay. Stator can't rotate. So I am using this. Stator can't rotate. And this is your rotor. Rotor is free to rotate. Yes, sir. It's a squirrel cage induction motor, so supply is only possible onto the stator side. Supply is given onto the stator at a frequency of F1. F1 is 50 Hz. So that produces a stator rotating magnetic field which rotates onto the stator body at a speed of ns. Ns is 120 F by P, 120 F1 by P. That will be equals to, pole is 6, so 6 and to 1000 rpm. So speed of stator flux with respect to stator body is 1000 rpm. Now while revolving round to the stator, this stator flux cuts the rotor conductor and induces EMF into the rotor conductor. As per the Lenz's law, induced EMF flows current such that it will oppose the relative motion between stator field and rotor winding, and therefore rotor will get started in the direction of stator magnetic field at a speed of nr. Slip is given to you, so you know about nr. nr is ns 1 minus s. So 1000, 1 minus 5% means 0.05. 5% of 1000 means 50, 14, 950 RPM. So 950 RPM. Now rotor is rotating at a speed of 950 RPM and stator field is rotating at a speed of 1000 RPM. Yes, sir. Speed of rotor with respect to stator magnetic field. We need to find speed of rotor with respect to stator magnetic field. So rotor speed with respect to stator magnetic field. 950 minus 1000 means minus 50 RPM. Actually, rotor is rotating with respect to stator magnetic field at a speed of minus 50 RPM. Is it okay? Yes, sir. It is slipping fast from 50 RPM. Yes, sir. Now, because of the relative motion between field and winding, there will be an induced EMF onto the rotor. The frequency of induced EMF is P delta N by 120, where delta N is the relative speed between field and winding. So this will be equals to SF1. S is 5%. So 5% means 2.5 hertz. Now for 2.5 hertz, this rotor will also produces a rotating magnetic field. Rotor rotating magnetic field with respect to rotor body will become 120 F2 by P. When you put F2 to be equals to 2.5 hertz, so 120 into 2.5 by 6, again 50 RPM only. This is rotor south. So rotor speed onto the stator body is S NS plus NR, that is again equals to NS only, 1000 RPM only. Basically this is 950 plus 50, that is 1000 RPM with respect to stator. So onto the stator body, if you observe, the relative speed between the two field is 0, and onto the rotor body, if you observe, the relative speed between the two field is 0, because stator field with respect to rotor is 50 RPM, NS minus NR. This is rotating at a speed of NS and this is rotating at a speed of NR. So NS minus NR, this is also 50. So 0 and minus 50 RPM is the correct answer. How many of you are able to understand this question perfectly? Great, sir. One more question, please observe. The power input to a 500 volt 50 hertz 4 poles induction motor running at 975 RPM is 40 kilowatt. So we have an induction machine. We all know about the power flow diagram. Input power to the induction machine is 40 kilowatt. Yes, sir. If the total friction and windage losses are 2.5 kilowatt, friction and windage losses is in rotational losses. So friction and windage losses is 2.025 kilowatt. Yes, sir. The power input is 40 kilowatt. Yes, sir. When motor is running at a speed of 975 RPM. Yes, sir. Here I am representing rotor copper loss. Is it okay? Yes, sir. Now please observe. Total stator losses are 1 kilowatt. Stator will have two losses, that is a stator copper loss and core loss. Both equals to 1 kilowatt. So air gap power will be equals to this 40 minus 1, 39 kilowatt. 39 kilowatt. Yes, sir. And we also know about slip. So since we know about slip S is equals to NS minus NR upon NS. NS is, this machine is of 6 poles. So 120 F by P, 50 hertz. 120 F by P is 1000. So this will become 975. 1000 minus 975 divided by 1000. Yes, sir. So if we know about slip, then we can calculate developed power. Developed power is 1 minus SPG. So developed power will become 1000 minus 975. 1 minus answer multiplied by 39. 38.025 kilowatt. When you know about developed power, you can calculate output power as well. And efficiency will become output upon input into 100. Yes, sir. So 38.025 minus 2.025, 36 kilowatt, and efficiency will become 36 by 40 into 100 means 90%. So efficiency will become 90%. How many of you are able to understand this question perfectly? How many of you are able to understand perfectly? How many of you are able to understand this question perfectly? Great, sir. See, one more question. Please observe. Figure shows a per phase equivalent circuit of a 2-pole 3-phase induction motor operating at 50 Hz. Air gap voltage Vg across the magnetizing inductance is 210 volt RMS. The slip S is 0.05. Torque produced by the motor in Newton meter is. So you know about the voltage here, 210 volts. And definitely it's a per phase indication. So it's a per phase voltage. Okay. Yes, sir. We need to find torque. What is torque? Sir, torque is 3 by omega Sm into I2 dash square into R2 dash by S. What is the value of I2 dash? Here you have I2 dash. See, the power transferred from stator to rotor is air gap power. Air gap power upon omega Sm is your torque. So this will become 3 by 4 pi F. F is 50 Hertz by pole is 2 pole into I2 dash. I2 dash will become voltage 210 volt square divided by R2 dash by slip square plus of x2 dash 0.22 square into 0.05 by 0.05. Yes, sir. This will be the value of torque produced by the motor. So 1 plus of 0.22 square 210 square divided by answer multiplied by 1 into 6 by 4 by 50 by 401.68 Newton meter. So easy. You can easily do this kind of question. Directly you need to put it onto the calculator. Yes, sir. Please observe this question. A 3-phase 50 Hz square wave voltage source inverter feeds a 3-phase 4-pole induction motor. The voltage source inverter line has a dominant fifth harmonic voltage component. If the operating slip of the motor with respect to the fundamental component is 0.04, the slip of the motor with respect to the fifth harmonic component is. See how to calculate. How to calculate, please observe. This is your stator. Because harmonic is present in the supply. Harmonic is present in the supply. Yes, sir. So it's a time harmonic. Time harmonic is a high speed rotating harmonics. Fundamental component is rotating at a speed of ns. Yes, sir. Fifth harmonic is 6m minus 1. All 6m minus 1th time harmonic will rotate at a speed of 6m minus 1 times of ns in the opposite direction, and all 6m plus 1th harmonic will rotate in the direction of fundamental. So this will rotate at a speed of 5 ns in the opposite direction, fifth harmonic component. Yes, sir. Now, rotor is rotating at a speed of nr. nr is with respect to the fundamental. With respect to the fundamental, ns is 120 f by p, 50 hertz, 4 1500 into 1 minus 0.04, 1440 rpm. So rotor speed is 1440 rpm corresponding to the fundamental flux. Yes, sir. If we talk about what is the slip with respect to the fifth harmonic, so rotor is moving on that direction and fifth harmonic component is moving on this direction. So slip with respect to fifth harmonic will become ns5, fifth harmonic will rotating at a speed of 5 ns minus nr. Why? Because rotor is rotating opposite to the direction of fifth harmonic component. Yes, sir. So these two are going to be added, divided by 5 ns. So this will become 7500 this will become 7500 plus of 1440 upon 7500. So slip with respect to fifth harmonic will become 1.192. How many of you are able to understand this part perfectly? Siddharth Chaube, what happened, beta ji? How many of you are able to understand this part perfectly? See, in case if the time harmonic is present, then it will be multiplied by the order of the harmonic. But in case if the space harmonic is present, then space harmonics are low speed harmonics. For a space harmonic, that will become ns by 5. For a time harmonic, that will become 5 ns. Is it okay? Time harmonics are high speed rotating harmonics. Time harmonics are present in supply voltage or supply current. However, space harmonic are only present in due to the saturation winding arrangement or slottings. So please keep remember this part. 1.192, it is 1.192 beta, 1.192 Kevin. Great question. Please observe this one. This question has two parts. Okay, let's first discuss. A three-phase 440 volt 50 hertz 4-pole slip ring induction motor is fed from a rotor side through an auto transformer, and the stator is connected to a variable resistance as shown in the figure. The motor is coupled to 220 volt separately excited DC generator feeding a power to a fixed resistor of 10 ohm. 2 wattmeter method is used to measure the input power to a three-phase induction motor. Variable resistance is adjusted such that motor runs at 1410 rpm. Variable resistance, this one. Okay. So rotor resistance is changed so that motor runs at 1410 rpm, and the following readings will be recorded. W1 is 1800 watt and W2 is 1600 minus 200 watt. The speed of rotation of stator magnetic field with respect to rotor structure will be. The speed of rotation of stator magnetic field with respect to rotor structure will be. Supply is given to rotor. Whenever supply is given to rotor, rotor will get started opposite to the direction of rotating magnetic field. Whenever supply is given to the rotor, rotor will get started opposite to the direction of rotating magnetic field. Yes, sir. Please observe here. Please observe here. Suppose this will be a stator and this will be a rotor. Okay, so it's a slip ring induction machine. Supply is given onto the rotor. Stator is fixed. Stator can't move. Stationary. Yes, sir. Supply given to the rotor 50 hertz 4-pole. So 50 hertz supply is given onto the rotor. Because of the supply given to the three-phase rotor, rotor will create a rotating magnetic field, and rotor field will start rotating Let us suppose in a clockwise direction at a speed of ns, where ns is 120 f1 by p, so 1500 rpm, 4 pole 50 hertz. While rotor north rotating onto the rotor, it cuts the stator conductors. Yes, sir. And there will be an induced EMF onto the stator. You can easily think that if I am going to hit with the suppose with some stick, if the things can move ahead, it will move ahead. Otherwise, my stick will go back. If I hit something to the wall, then wall will remain at its own position. The stick will come back. Yes, sir. So what happened? The induced EMF onto the stator is such that it will create a current which opposes relative motion between rotor field and stator winding. In order to oppose relative motion between stator field and rotor winding, if it is possible that stator will get started in the clockwise, in the same direction. But since stator can't move, so rotor will get started in the opposite direction at a speed of nr. Is it okay? Yes, sir. What is the speed? It is given that the speed is 1410 rpm. So rotor is now moving at a speed of 1410 rpm. At this instant, the flux cutting with a stator rotor flux cuts the stator conductor at a speed of ns minus nr. So this will be equals to 90 rpm. Is it okay? Yes, sir. So there will be an induced EMF onto the stator, that is P delta n by 120, where delta n is 90, 4 pole 90 divided by 120. That will be again equals to SF1. SF1 is the same as slip times of F1. Okay? Yes, sir. So 4 into 90 by 120, 3 hertz. Because of the 3-phase stator, there will be a stator flux which is also rotating with respect to stator body. Now it will rotate at a speed of 120 into F2 by P. That will be equals to 90 rpm again. When you put F2 as 3, 4 pole, so it will be again 90 rpm. So what is the speed of stator flux with respect to stator body? 90 rpm. What is the speed of rotor flux with respect to stator body? 90 rpm. And in the question, we need to find stator magnetic field with respect to rotor structure. So what is the speed of stator magnetic field with respect to rotor structure? So rotor field with respect to rotor structure 1500 rpm. So stator field with respect to rotor structure must be 1500 rpm for a machine to operate, because the must condition for production of steady state electromagnetic torque is relative speed between the two field must be 0. So this shows, sir, stator field onto the stator body at a speed of 90. Yes, sir. And rotor is moving in the opposite direction at a speed of 1410. So this will be 1500 rpm. So the speed of stator field with respect to a rotor body or winding will be equals to 1500 rpm opposite to the direction of rotor. Opposite to the direction of rotor. And that is the must condition for production of steady state electromagnetic torque. Two field must be 0. The relative speed between the two field must be 0 with respect to each other if you are going to observe onto the stator body or onto the rotor body. So this shows that, sir, 1500 rpm opposite to the direction of rotation. 1500 rpm opposite to the direction of rotation. Is it okay? How many of you are able to understand up to this part? Great, sir. The same question will have one more part. In the previous question, neglect all losses of both the machines. The DC generator power output and the current through the resistance R external is. See, basically induction machine is feeding to DC generator. and DC generator is supplying R external. Is it okay? Yes, sir. So whatever power is your developed power is the input power to the generator, and input power to the generator is output power to the generator. That will be equals to I square R external. Power is going to be consumed here. Is it okay? Yes, sir. So, what is developed power obtained from the induction machine? What is developed power obtained from the induction machine? Sir, the input power to induction machine is W1 plus W2. So, input power to induction machine, air gap power is input power to induction machine. So, 1 minus SPG, you can write input power to induction machine is 90 by 1500. 0.06 is your slip into 1410 RPM means 1500 minus 1410 divided by 1500, 0.06 slip, and W1 plus W2 is your air gap power. Yes, sir. So 1800 minus 200, 1600. 1800 minus 200, because W1 is 1800, W2 is minus 200, 1600. So 1 minus answer into 1600. We have 1504 watts. From this we are able to calculate the answer. But let's talk about current as well. So this R external value is also given to you as 10 ohm. What will be the current? IA will become, sir, output power 1504 divided by 10 root over. So 1504 divided by 10 root over answer 12.263 ampere. So we have this one as a correct answer. How many of you are able to understand this question perfectly? Great, sir. Hoping all of you are able to understand this question perfectly. Great, sir. Let's talk about one question from the synchronous machine as well. Please observe this one. Hoping all of you are able to understand up to this part perfectly. Great, sir. Now please observe this one. A 3-phase 11 kV 50 Hz 2-pole star connected cylindrical rotor synchronous motor is connected to an 11 kV 50 Hz source. Its synchronous reactance is 50 ohm per phase and its stator resistance is negligible. The motor has a constant field excitation at a particular load torque. Its stator current is 100 ampere at unity power factor. If the load torque is increased so that the current will become 120 ampere, then load angle at this particular load is. Good one. Please observe. We have a cylindrical rotor synchronous generator. Synchronous motor. Cylindrical rotor synchronous motor. Yes, sir. Please observe. Please observe. This motor is connected with a 11 kV 50 Hz source. So 11 kV, you can take it as a reference per phase voltage. Synchronous reactance of 50 ohm. So we know about JXS. And armature resistance is negligible. Motor has a constant field excitation at particular load torque. At particular load torque, its stator current is 100 ampere at unity power factor. So sir, we have EF phasor is equals to V phasor minus of 𝐂𝐸𝐴 phasor. Can we write in this way? Yes, sir. Let's put the values also. So per phase voltage is 11 into 10 to the power 3 by root 3. Per phase voltage will become 11,000 by root 3, 6350.85 volts. Yes, sir. Armature current is given to you 100 ampere and power factor is given to you unity. Yes, sir. So EF at an angle minus delta will become 6350.85 at an angle 0 minus IA. IA is 100 at an angle 0 into XS 50. Very easy to calculate. Real part, imaginary part. Yes, sir. So minus of 100 into 50I. (8082.90 minus 38.21 degree). So we have EF at an angle minus delta. Is it okay? Yes, sir. Now the value of excitation is kept fixed. Please observe from the phasor diagram as well. If we take V as a reference and at unity power factor current is in phase with the IA. Yes, sir. So JIA axis is 90 degree to the IA. I am subtracting. So if this is IA, this side minus IA, downward minus of JIA axis, this will be your EF1. Okay. Already we have calculated the value of EF1. It is given that the excitation is kept constant. Excitation is kept constant. Yes, sir. And load onto the motor is changed. So excitation is kept constant and load onto the motor is changed. Now the load is changed such that the motor will start drawing a current of 150 ampere, 120 ampere. So when motor draws a current of 120 ampere, it means definitely the load is increased, because then only the current will increase. So this will be your new IA2 axis. Magnitude wise it is IA2 axis. For phasor you may represent like this. However, in phasor diagram we never represent J term, but I am representing just to show you the equation. Okay. Yes, sir. And magnitude of this will remain same. EF magnitude will remain same. EF2 magnitude will remain same. But load angle delta is going to be changed from delta 1 to delta 2. And also your armature current will become lagging. Your armature current will become lagging. New armature current will be somewhere here. So power factor is going to be lagging. Is it okay? How many of you are able to understand this part perfectly? From the phasor diagram, excitation will remain same and megawatt is increased. Excitation is remain same and megawatt is increased. Is it okay? Yes, sir. We all know that excitation will remain same and megawatt is increased. So we all know that IA axis will be if you are able, if you want, you can observe here also. What is IA axis? This is your EF2 cos delta. EF2 cos delta 2. Yes, sir, this is V. So the difference is EF2 cos delta 2 minus V square. I'm showing you this part. Okay. Further, if you observe, we have this part. This is your EF2 sin delta 2. Yes, sir. So hypotenuse square can be calculated as perpendicular square plus base square. We are able to see this right angle triangle. So here this will be your EF2 sin delta and this will be your EF2 cos delta. So you can calculate IA2 axis magnitude. IA2 axis magnitude. So IA2 axis will become equals to root over of, when you open this, it will become EF2 ka square plus V square minus of 2V EF2 cos delta 2. Yes, sir. From here you can calculate cos delta 2. It means new load angle you can calculate. So what will be your new load angle? New load angle will become EF2 square plus V square minus IA2 axis square upon 2V EF2. Even you can calculate delta 2 directly. This is a load angle equation. So cos inverse. What is EF2? 8000. EF2 is magnitude is equals to EF1, 8082 point. I'm explaining you, that is why, otherwise you can directly put the values, okay? V is 6350, 6350.85 minus of 120 into 50 square divided by 2 into 6350.82 into 8082. So we have delta 2. How many of you are able to understand this question perfectly? So 8082.9 square plus of 6350.85 square minus of 120 into 50 square divided by 2, 6350.85, 809. Cos inverse answer. Definitely it will be increased. In case if the options are given, it will be very easy. But since the options are not given, we have to observe. Yes. Kevin, absolutely right. So how many of you are able to understand up to this part? How many of you are able to understand up to this part? Great, sir. One more question, please observe. A synchronous motor is connected to an infinite bus at 1 per unit voltage and draws 0.6 per unit current at unity power factor. Synchronous reactance is 1 per unit and resistance is negligible. Excitation, voltage and load angle will respectively be. See, EF phasor is equals to V minus of JIA excess phasor. So we have 1 per unit minus of J 0.6 at an angle 0 into excess is also given to you as 1. So 1 minus J 0.6, this will become 1.166 at an angle of minus 30.96. EF at an angle minus delta. So EF excitation voltage 1.17 and delta is 30.96. Of course, when we talk about delta, it's a lag. Negative angle is for the lag. This is lagging from the terminal voltage. EF is lagging from the terminal voltage by 30.96 degree. So this will be the correct answer. Hoping you can easily do such kind of questions. Yes, sir. Very similar with the same, everything same, just it's a generator. Let me do it for the generator also. A non-salient pole machine, synchronous generator having synchronous reactance of 0.8 per unit, supplying 1 per unit power to a unity power factor load at a terminal voltage of 1.1 per unit. So power is equals to VI cos phi, and I will become 1 per unit divided by 1.1 into 1 means 1 divided by 0.1.1, 0.909. This will be your current. Further, neglecting armature resistance, angle of the voltage behind the synchronous reactance with respect to the angle of the terminal voltage in degrees is. So EF phasor क्या हो जाएगा? EF phasor will become V phasor plus of JIA excess phasor. Yes, sir. And 1.1 at an angle 0 plus of JIA is 0.909 angle unity power factor only multiplied by excess is 0.8. So you can calculate the angle as well. 1.1 plus J 0.72. So neglecting armature resistance, the angle of the voltage behind the synchronous reactance with respect to the angle of the terminal voltage in degree is. Terminal voltage lags the excitation voltage by an angle of 33.47 degree. 1 per unit power to a unity power factor load at terminal voltage of 1.1 per unit. Neglecting the armature resistance, angle of the voltage behind the synchronous reactances. How many of you are able to understand this question perfectly? How many of you are able to understand this question perfectly? Done? Need 1 minute. Sir, based on the speed droop questions. Parallel operation, you are talking about parallel operation, beta? Let me check. Maybe actually I have kept a lot of questions, but the time is not sufficient to discuss all. You want a speed drop, na? Speed droop, characteristic based question. Okay, see this one. This one is a speed droop based question. Okay, Ashutosh, see. A 50 Hz synchronous generator on droop control was delivering 100 megawatt power to a system due to increase in load. Generator power had to be increased by 10 megawatt, as a result of which system frequency drooped to 49.75 Hz. Further increase in load in the system resulted in frequency of 49.25 Hz. At this condition, the power in megawatts supplied by the generator is, see, whenever load onto the synchronous machine increases, because of load torque, generator speed decreases, and due to the decrease in the speed of the generator, frequency of the generator decreases. Is it okay? So either they can give in terms of percentage regulation of the turbine, or they may give you the droop in terms of frequency. Okay. Now see, we have a 50 Hz generator. We have a 50 Hz synchronous generator. On the droop control was delivering 100 megawatt power to a system at 50 Hz. So it means at 50 Hz, it gives 100 megawatt of power. At 50 Hz, it gives 100 megawatt of power. Is it okay? Due to increase in load, generator power had to be increased by 10 kilowatt. Okay. As a result of which system frequency dropped down to 49.5 Hz. So when 10 megawatt is increased, then what will the load become? 110 megawatt. So while delivering 110 megawatt, frequency dropped down to 49.75 Hz. Please observe, Ashutosh. Further, increase in load in the system resulted frequency to 49.25 Hz. Further increase in load. If we increase load further, then frequency will be reduces to 49.25 Hz. Let this load to be P. Okay, we don't know about the load, so just take it as P. It's a megawatt axis. This is your frequency axis. So we need to find the load P megawatt. Are you able to understand? Yes, sir. Now please observe. While delivering 100 megawatt load, its frequency is 50 Hz. While delivering 110 megawatt load, its frequency is 49.75 Hz. Can you find the value of the slope? Can you find the slope? Yes, sir. Y2 minus Y1 upon X2 minus X1. Slope is negative. Yes, sir. I am interested in magnitude. Let's calculate the value of slope. So slope is Y2 minus Y1, 49.75 minus 50 divided by X2 minus X1, 110 minus 100. So slope is negative. Definitely it's a drooping, so slope is negative. 49.75 minus 50 divided by 110 minus 100. Okay. So negative of 0.025 is your slope. Is it okay? Yes, sir. Now suppose we have a no load frequency FNL, and this is your system frequency F of the system. Now it is operating at here. Yes, sir. So for the same slope, can you write? Please observe. For the same slope, you can write megawatt as, for the same slope you can write sir y2 minus y1 upon x2 minus x1. We can compare the magnitude of the slope. What is the magnitude of the slope? Magnitude of the slope is 0.025. Yes, sir. Magnitude of the slope, you can also write y2 minus y1. So P 49.25 minus y1, you can put 50 upon x2 minus x1. Can I write like this? Yes, sir. I'm interested in magnitude only. Okay, so magnitude will be equal. So 49.25 minus 50.75 divided by 0.75 divided by P minus 100 is equals to 0.025. So you can calculate the value of P. +30 plus 100, 130 megawatt. How many of you are able to understand this question perfectly? Yes. Please let me know by writing in the comment section. Can you do this kind of questions? Okay, I need your attention for a little while more. See, in case if two or more alternators are operating in parallel, and they will have different drooping characteristics. Suppose if we have an alternator 1 will have a drooping characteristic no load of alternator 1, and this is your full load frequency of alternator 1. This is for generator 1. So we have megawatt 1, and another alternator will have different drooping characteristics. Suppose this one, this is no load frequency of alternator 2, full load frequency of alternator 2, generator 2. Is it okay? Yes, sir. When these two generators are operating in parallel to feed some load, suppose total load is PT, then generator 1 will deliver P1 load and generator 2 will deliver P2 load. So under such a condition, we have one relation PT as P1 plus P2. Okay. Another thing is we can calculate the value. Please observe. We have a relation. This angle theta1 is theta2 is equals to theta2. So tan theta2 is equals to tan theta2. What is tan theta2? Sir, perpendicular upon base. So perpendicular is FNL2 minus, this is operating system frequency. Okay. So I am representing F of the system upon P1 is equals to theta2 is this bigger one, FNL2 minus FL2 upon megawatt of alternator 2. That may be a rated or a full load of the alternator 2. Is it okay? Yes, sir. From here you may write P1 as, let it be equation number 1, and it can be further, this is your equation number 1, it can be further represented as P1 as FNL2 minus F of the system, FNL2 minus F of the system megawatt 2 upon FNL2 minus FFL2 into FNL2 minus F of the system. Okay, so this will become megawatt 2 upon, please observe here, it can be represented as 1 upon magnitude of the slope, FNL2 minus F of the system. In same way, like I did for this. In same way you can write for theta 1 and theta 1. And for theta 1 and theta 1, if you calculate, then P1 will become 1 upon S P1. Slope will be megawatt rated divided by FNL2 minus F of the FFL2. This is the slope of the droop. Okay. So FNL1 minus F of the system. Now we have P1 and P2. So you can put in this equation in order to calculate the system operating frequency or kilowatt shared by each of the alternator during parallel operation. So this is very helpful when n number of alternators are connected in parallel to feed load. Hoping all of you are able to understand. Ashutosh, I am hoping that part you wanted to ask, huh? I haven't kept any question because some PYQ questions are being represented here, that is between 2008 to 2020, but hoping now you are able to understand. Also, I made one particular question with you, so hoping now you are able to understand. One more question. A 25 kVA 400 volt delta connected 3-phase round rotor cylindrical generator requires a field current of 5 ampere to maintain rated armature current under short circuit condition. For the same field current, open circuit voltage is 360 volt. Neglecting armature resistance and magnetic circuit saturation, voltage regulation when generator delivers rated load at 0.8 power factor leading at the terminal voltage is. So we need to find the voltage regulation. Only we have one method, that is MMF method. MMF method. But here access is given. Please observe field current of 5 ampere to maintain rated armature current. So at a field current of 5 ampere, there is a rated armature current under short circuited condition. So in a short circuit characteristic curve, we know how to calculate the value of ISC. Okay, ISC is given to you. ISC is rated current at a field current of 5 ampere. So ISC is equals to I rated at 5 ampere of IF. Yes, sir. Further, it is given that for the same field current, open circuit characteristic will give 360 volts. Okay, because it's a delta connected, so phase voltage and line voltage is same at 5 ampere. Is it okay? Yes, sir. At a field current of 5 ampere, rated armature current under short circuited condition. So rated armature current, we can calculate line current and then we have a phase current. Is it okay? So we need to know about the per phase current, per phase rated current. Armature resistance is negligible and magnetic saturation is also neglected. So excess will become VOC by ISC at same IF. Yes, sir. At same IF. Is it okay? Yes, sir. VOC by ISC at same IF. Now, what is the value of ISC? ISC is equals to I rated. So rated per phase current. Rated current is 25 kVA divided by root 3 times of line voltage into root 3. Why I'm doing this? Phase current, for finding phase current. This is your line current. This is your line current. You can calculate phase current as well. You can calculate phase current. So phase current will become 25 into 1000 divided by root 3 divided by 400. Okay, 36.084 divided by root 3, so 20.83 ampere. Now we have excess in ohms 20.83 divided by 360. 360 divided by 20.83. So 360. Now we have excess. Once we have excess, we can calculate EF. EF in magnitude is root over of V cos phi. RA is neglected. V sin phi plus of IA excess square. Plus or minus, whether it is at leading power factor or lagging. Leading means generator. Leading means under excited. Under excited means this is minus. Minus is used for under excited. Plus is used for over excited. So root over of voltage V, we have voltage V as 360 volt. Voltage V is 400 volt. Terminal voltage is 400 volt. Line voltage and phase voltage is same. Cos 5.8 square plus 400 into 0.6 minus of IA. IA we have, what is per phase current? Per phase current is 20.83. 20.83 into excess. What is the value of excess? 17.32. 360 only. 17.32. 360 only. So this will become 400 into 0.6 minus 360 square plus of 400 into 0.8 square root over answer 341.76 volts. Once you have EF magnitude, voltage regulation will become EF magnitude minus V upon V into 100. So minus of 400 divided by 400. Minus of 14.55%. So we have minus of 14.55%. Are you able to see this? We need not to calculate the value. Actually, you need not to calculate. You are knowing that 360. It means you know about IA excess. Under rated condition. Under rated condition. In case if it is not a rated condition, then we have to calculate. But since we are talking about the generator is delivering rated load. So under rated condition, your ISC and IA is the same. So that is again going to be 360 only. You need not to calculate all these things. If you are able to understand, please observe. Yes, sir? Is it okay? Great. So that's all about today's class. I am giving, you can connect with me on my Telegram for more questions. If you have any doubt in any topic, please feel free to connect on my Telegram @VarunSirPW. Thank you everyone. Lots of love. Thank you everyone.